All right, so let's welcome all the participants to the Center for Transportation and Logistics Research webinar. As you know, the center hosts several practitioner and academic talks from rich expertise researchers as well as practitioners. Today, we're extremely fortunate to have with us Professor Michael Lind. Michael Lind is the world's first adjunct professor of maritime informatics and is engaged at Chalmers and Research Institute of Sweden. He's an expert contributor at the World Economic Forum, Europe's Digital Transport Logistics Forum, and UN. From what I recollect from several years that I know Michael, he has been a very prolific writer, and he has been writing several cutting-edge articles on maritime digitization. And as not only the world, as India is also focused quite a bit on digitization and is trying to figure out new frontiers in digitization and improving the efficiency of supply chains, maritime plays a significant role for India as well. So we are extremely fortunate with us to have this talk on maritime informatics. The title of the talk is, How Can Maritime Informatics Sustain Transportation and Logistics and also improve the performance? So without too much of delay, let us welcome Professor Michael Lind, who is also a co-author of several books in maritime informatics, including the Practical Playbook for Maritime Decarbonization. So without further delay, let's welcome Professor Michael Lind, and the floor, rather the Zoom is yours. And participants, if you have any questions as the talk progresses, feel free to write those questions in the chat or the Q&A section. We'll be taking them as soon as we get the opportunity. Yeah, so please, Professor.
Thanks a lot. And let me just check here now if you see my screen. Which screen do you see?
We see your PowerPoint, but not in the slideshow mode yet.
No, that I will fix now here.
Yes, it's great. Yeah.
There we go. Okay, everyone. Fantastic to be back in India. Let me call it that. I was participating in the Maritime India Summit. I don't know, my feeling was that there was like 250,000 people or something like that in that summit. It was enormous. And this was during the COVID times back in 2021. And I was fascinated how well you managed to use digitalization in order to bring people together in different ways. So I will be trying to talk about maritime informatics for a high-performing and sustainable transportation and logistics industry today. And that is heavily building upon the idea that you cannot do large-scale digitalization without large-scale collaboration and vice versa, if you want to derive or arrive at both economic value and societal value. When I was doing this talk for the Maritime India Summit, I had my colleagues at Marine Benchmark making this illustration for me. And it's fascinating to see what you can do with data. These were, back in 2021, the patterns of transport between Asia and Europe. And you see it's very many that goes through the Suez Canal. I guess that we are somewhere in India where you have now a pretty big bunch of ships that are coming in and visiting you. I guess that's where we are on this peninsula out there. We also see that Sri Lanka seems to be a very important hub as well with Colombo. I hear that there's a lot of empty containers in Colombo that some shipping lines come and pick up. However happened, and I got this from this morning. This was a work that the same company did for UN, looking into what is happening with the trade, and this again is drawn out from AIS signals. And here you see how we more and more ships are going around Africa, and here, as you see, towards 15th of February, it's almost empty in the Suez Pond, and this is due to This is due to the fact what has happened, what we now in Northern Europe coin as the Rocket Festival in Suez. So maybe I shouldn't say that, but it's totally insane what is going on. And this, I guess, also, if you look at the two routes that goes out of Africa, some ships are heading towards Sri Lanka. But I guess that this Suez effect also puts a little bit of isolation to India in this case. I don't know what that would mean, but I can guess that it's at least it is fewer ships that are close by. So what I will try to talk about today is why was there a need for something called maritime informatics, and I think that we should translate it and think about it as the efforts of digitalizing sea-related operations, transports type of thing. So it has something to do with the maritime sector at least. So I will give some kind of background on that, and then we will explore a little bit of the foundations of maritime informatics, not super deep, but a couple of things that are foundational. And then I will bring forward 3 areas of application responding to global challenges that are powered by digitalization in one way or the other. And the way I conceive maritime transport and logistics operations is basically that is very many times in a transport and logistic process, the goods or the passengers that we are transporting are touching keel somehow, but it's also not. It's in very few cases that everything ends up in the port. It's very often connecting to another mode of transport. And then some concluding words. And as Professor Debbie Joy said, please put your comments in the chat, and then we will see whether we can respond to those when I've talked for a while. So welcome everyone, and here comes some perspective from the European side on this. So first of all, there is an academic field called information systems, which is basically about taking making let me call it eclectic soup out of social science and natural science, and trying to bring value out of digital technologies for users in different ways. What we wanted, and what informatics is in itself, is to be coined as an applied science. It is not having too many years behind. I would say in the 50s or the 40s or 50s maybe, when computers came to the arena. I think that Börje Langefors would be one of the founders, which actually was a Swede, but he was very concerned of that we also should ensure that what comes out of digitalization should be of value for humans and for society. If you read it now, I would say that it takes a strong socio-technical science or basis. I think that we suffer a little bit now when we see what you can do with ChatGPT, for example, or those kind of technical tools in different ways. And I often claim that you can never detach the human agency from technology. It is also a science for change, and what we see is that when you introduce different types of digital artifacts into human settings or organization settings, you see that there's a change of behavior. And also it is relying on eclectic foundations, meaning that it borrows a lot of different components, or the science borrows a lot of different components from different sciences. Now I have this one. I haven't updated it after 2020, but here you see that a lot of the world's trade is carried by sea. We have an enormous growth rate, and it is also having a large portion of the estimated global CO2 emissions back in 2019, and we know that the curve of the amount of CO2 emissions is not really dropping at all. The maritime ecosystem is very unique. It is what many say is the oldest and largest sharing economy. It is global, meaning that it engages many different parts of the world, and it's affected by many different parts of the world. It is flat in the sense of that there's no overarching boss that will tell how things are working. It is self-organized, meaning that you as an actor, if you are engaged in this system, you need to coordinate with others in order to make the best profit out of your operations, and also bring the best sustainability to it. One example is, of course, just-in-time ship arrivals to port. It is building upon what we call a federated and democratic governance. It is asset intensive. If you think about how much the cost is for a ship, for example, or for a port, with high demands on optimized resource utilization. It does not, as happens in the case of Apple, it does not allow for one owner. I have several interactions with large shipping companies, and they are extremely concerned of not being the copycat of the other one, so to say. So everybody wants to be first, and not doing this together. And finally, it also builds up on episodic interactions, meaning that you will be tightly connected for a certain time or period, such as during a port visit, but it also it can be the case, especially in the bulk sector, that you only visit one port one time, type of thing. So no single keystone organization, distributed control, and loosely coupled organizations that are adapting autonomously and organically to each other. So what we felt is that digitalization has the power and opportunity of actually contributing to a better coordination, performance, predictability of the sector. So what we did back in, I think it was in 2013, 2014, 2015, my colleague and friend, Richard Watson, he gave a first talk on maritime informatics and said that this is a golden opportunity for the maritime sector, bringing both practitioners and scientists together in order to forward a thinking on the digital uptake in the maritime sector. Even though that we're very fast in bringing AIS to the table, or to the world, meaning that each commercial ships should have or must have an AIS transponder sending a signal every 6 seconds, and that has now been in place for the last 20 years, taken up by IMO, and also a Swedish invention. That AIS signal needs to signal speed and direction and position every 6 seconds, and that means that we can also get a pretty good understanding on where this what is happening in the maritime sector. And so we have done a lot of analysis and showing that, for example, this image on ships that are now not going through Suez Canal, going around Africa. We had another case with all the congestions. We had about the size or the yearly production of Port of Gothenburg was waiting outside Port of LA and the Port of Oakland. And what did the ships do while they were waiting? Did they anchor, or did they do something else? And they did not anchor. They were drifting and then speeding back again, or steaming back again, consuming a lot of nautical miles, or making a lot of nautical miles, or you may say also bringing a lot of pollutions to the world. So what in the emergence of this science, so to say, we have had a number of different actors, and I've collected some of them on maritimeinformatics.org. Voices that have said that the COVID-19 crisis has given a further push to maritime informatics and the digitalization of logistics. That is from UNCTAD, Jan Hoffman. We have Lars Mathiasen, which is a very important professor in informatics. We have the head of digitalization at the Port Authority of Hamburg, Hans-Jan Struesendam. Andres Sima is the CDIO of MSC, the largest shipping company. I think it's actually Indian-based also, isn't it? and Michael Rance, who was sitting on the IIMA committee. So with a high effort of pushing efficiency and sustainability, maritime informatics has been brought as a concern for many. So what did we acknowledge as a need? We think that one thing that is extremely important is to connect what happens at sea with what happens at shore. We need to enhance the predictability of movements and operations. We need to increase the information transparency with direct and indirect stakeholders. We need to seamless integrate with the multimodal transport chain, with the argument that I used before, that not much of the seaborne traffic is ending up in the port. And also that we need engaged scholars as well as reflective practitioners joining the same discourse, which we then coined as maritime informatics. And the trends in the maritime sector, it's really that it's when it's coming to what we see in digitalization or digitalization associated concerns, is that we move from a fragmented situational awareness to a common situational awareness. We move from low information quality to high and reliable information quality. We move from lacking planning horizons to predictable operations. Unstructured information exchange to standardized data exchange, from sub-optimized operations to a mature collaboration culture. Unnecessary waiting times to just-in-time operations. I put a lot of question marks here because I think it's this effort is not really solved yet. My screen is changing. And why I'm saying that is also that I think that it is conceived that 75–80% of all the ports in the world do not have the enough digital capabilities implemented in order to be more slot time management oriented. And I used to do that. I traveled to a lot of ports and I asked and said that I would like to be, I will visit you in 2 weeks. Can I please book a slot? And they normally just say to me that you can, we take you as you come. And then we have a low IT maturity, and I think that's it's enhanced IT systems and third-party innovation opportunities that are emerging. So what is then maritime informatics? This thing we said pretty early. We said that it is focused on collaboration and digitalization. It should balance between capital productivity, meaning raising the capital, and that could be different types of capital, which I will show soon, of the single organization that is involved, but also energy efficiency, which basically bounce back to the whole society. It also responds to organizational, global, and humanitarian concerns. And I did a work together with the World Economic Forum, and I think the conclusion there was that 8,000 to 10,000 people are dying every day due to the fact that they have no food. And of course, not the shipping sector is not the only to blame, but if we would be more transparent, we would have an opportunity to actually redirect another ship or whatever that could be in order to secure that we handle starvation in a good way. So 3 focus areas: digital collaboration, digital data sharing and decision making, and data analytics. And so far we have mainly, I say mainly, but so far we have mainly looked into commercial traffic or passenger and goods. But of course there are other things. I mean the whole fishing sector and also the whole leisure craft sector is could be applicational areas of maritime informatics. So what we coined it is maritime informatics is the application of information systems to increase the efficiency, safety, and ecological sustainability and resilience of the world's shipping industry. We have written 2 books that Spring has surfaced, and I think it is. I do not exaggerate if I say that there's more than 100 co-authors to those chapters in those 2 books. So it's not just a drive by Lind, Michaelidis, and Ward and Watson. It is a thing that actually brought a lot of people together. We have also tried to push and put all the articles that we have done on the website called maritimeinformatics.org. So the scope then of maritime informatics is that we want to support the innovation of the maritime ecosystem. We believe at the core is the ship operations, of course, but also port operations. Nowadays, we conceive port operations as something that is not only associated to the as a window to the sea. A port is also importantly has windows to other modes of transports, and that needs to be coordinated. There are a number of different concepts associated with that, like digital innovation, capital productivity, ecosystem innovation, digital collaboration. You have artificial intelligence, data-driven decision-making, digital twinning, smart ports, smart ships, etc., and smart containers also, or the connected goods. What is also a trend is that we see that the power of the shore-based monitoring and coordination becomes extremely important as well. And maybe you remember this cruise vessel Costa Concordia. I think it's called Costa Concordia. The ship that went ashore outside Italy when the captain were waving to his friends. Big lawsuit, and we have the Mare Liberium 1609. The captain is the king of the sea, but that grounding actually was coined as if the cruise industry would have another accident like that, that would probably be the death to the whole industry. Why Costa and other shipping companies then introduced the fleet management operations, where the captain basically had to file his route, and then if you would deviate from the route, you need to file a report on why you deviated from the route. So much more control from the shore side suddenly, and this is of course in the interest of the highly expensive ships that we're talking about. So Maritime Informatics wants to digitally connect people, goods, port, ships, and infrastructure, responding to the needs of other modes of transports, to passengers, cargo owners, and shippers for efficient, safe, and sustainable sea transports. Looking into the different capital creation or organizations as capital creation, many would talk about it and think about it that an organization exists to generate positive economic outflow, but there are other things that you can build as well. For example, if you're a student at the Institute of Management where we are today, that is probably highly valued. Or if I'm a student at MIT or any other top management schools, which means that basically you develop your symbolic capital. You might be part of a big relationship network. That means that you may also expand your social capital, your human capital by being more skilled, etc. So there are many different dimensions of capital creation. And that is also one of the arguments that I am using very often to inspire different organizations to be part of some of the initiatives that we are doing. Okay, if you're part of this one, of course, in the long run, you will earn more money, but just to be part of it now, it means that you will raise your symbolic value by just being there. So the Maritime Informatics also has a concern of or takes a very holistic approach to things. And the best word to describe this holisticness is by taking a system-oriented perspective. And we are using different system levels to bring attention to different concerns. What we would see is that very many often times we have a system of production that is based on a system of engagement, meaning, for example, that we transport something from point A to point B. That is a system of production. In order to get that working, you need to secure that you have a lot of agreements pursued, for example, when you can visit the port, etc. That production data can generate for us what we call a system of record, because that system of record is something that can be used for decision making in different ways. And also the system of record is then something that could be part of what we call the system of inquiry. And a system of inquiry is what you see and you use when you, for example, talk about this AI-based or big data-based applications in different ways. And when we learn more things about the system, we may actually challenge the existing predominant view of a certain system, that it should actually be this and this instead. And that's what we call system of framing. So there are different system levels, and we need to know where to be in those different system levels in order to pay attention to different concerns. And human and organizational interaction and communication patterns are essential to understand and conceive in this effort. So again, maritime operations is not just about bringing a ship from one point to another point as efficient as possible, and that the engines are working. It's a lot of humans involved in that effort as well, and different organizations, of course. So taking the perspective of maritime transports as a self-organized ecosystem or self-organizing ecosystem, I think that for me, it is that we need to rely on a foundational viewpoint of, first of all, bringing standardization to the table. We need to secure that everybody is talking by using the same language. I'm not opposing that there might be 10 different standards, but that is better than having 30,000 EDI connections to different clients. That I know that, for example, the legacy from the container shipping industry is now trying to respond to. Another thing that is also happening is that, in opposite for the aviation sector, things are not happening according to plans in the maritime sector. So you need to be able to collaboratively align. There might be bad weather, the ship might be delayed. That means that you can take another ship instead, prior to that ship that is going to visit that port. And if you think about, if you take Singapore as an example, which is one of my favorites, the port rotation that they do in Asia, where Singapore is the last port of call before going back to Europe, we are talking about a degree of maybe 80% of all the ships that are incoming are more than 24 hours delayed. And that is due to the accumulation of different waiting times in the previous ports. So we need to somehow collaboratively align. At the same time, we also need to bring different information sharing communities together. We have a lot of port community systems. We have ship management systems, etc. And those are bringing some actors together, but we also need to secure that those information sharing communities are talking to each other to support the alignment. And here, a lot of financial concerns also kicks in. And also, we have the appointment economy, and that is to be compared with if you go to the shop and you take a ticket that you want to be served, that you normally cannot acquire that ticket 2 weeks in advance, versus if you book a dentist appointment, you do that 2 weeks in advance, or you are even proposed when you should be at the dentist. So those 4 components is what we believe that can bring us to more smart operations. And what we conceive is smart operations in terms of sustainable and smart ports, smart ships, and intelligent cargo. And intelligent cargo, that means that we would be connected, or the cargo would be connected and can also provide us some situational awareness. For example, what is the temperature? Is it extremely hot, so that is a risk for fire on board the ship, etc. We may be empowered by data analytics, and there are different concepts such as data fusion, machine learning, and also what is extremely popular as of today is digital twins. I can say a lot of digital twins, but I will not do it today, but that could be another talk, David, when we come to that situation. And what we then hope for is that this provides a decision basis for balancing environmental sustainability and capital productivity. So what is then at focus and desired? We have we try to conceive enablers and effects, and the first phase, what we saw was that standardizing is very important. That driving us to data-driven decision making for collaboration and synchronization, on collaborative alignment and synchronize and coordinate operations, and also empower the decision making for the involved parties. And this in terms could then is expected to lead to intelligent integrated planning and execution with multimodal integration, and this then conceiving or managing capital productivity gains in terms of efficiency, resilience, safety, and sustainability. And this then, of course, feeds back all the way back to the standardizations. Do we share the right type of data, etc. in this? And we also made a in informatics, there's something called the OSI model, and we made an adapted OSI model for the maritime sector, or what we coined as the Maritime Informatics Stack, where we distinguish between data communications, data exchange, data stream mining, decision support, structural changes, regional national concerns, and at the top, the global concerns, where we need to ensure that we have an industry-wide international standards for digital data exchange within the maritime sector. Having said all this, and this is something that has been cooking for a while, what we then ended up with was to say that, hey guys, if you look at all the debate in the transport industry, we saw that, and all our efforts has been on digitalization and collaboration. So we saw suddenly that we need to bring this together in some kind of new paradigm that we have proposed, where we see that all industry need to place greater emphasis on the interrelationship between collaboration and digitalization. I will show an example of that a little bit further on here. As this powerful duo impacts economic and societal success through enhancing human and social capital and preserving and restoring natural capital. Focusing only on one of both dimensions of each pair, either on collaboration or digitalization, or on economic or societal value, leads to suboptimal results. So that would be, for example, if we just focused on CO2 emissions, that means that there will be some organizations that will not feel happy about it. If we just look at the economic success of a single organization, there might be other organizations that will be out of the game. So what we then did was that we started thinking about what other than not different forms of dependencies, and we identified 3 different types of dependencies, what we call sequential dependencies, and I think that is what we want to aim for. Success depends on a chain of single actors' prior success. If one actor in a sequential chain fails, the performance of the following actors is just jeopardized, and that is what we see in the case of Singapore with the port rotation. One port is really performing bad, and that affects everybody else in the chain. Pooled resources. Success is reliant on a group of actors working independently in parallel to complete a project. If one fails to meet its delivery commitment, the task fails, and that will be in the typical project management situation. And you can also see that if you are supposed to have a full fledged capacity utilization of a ship, and one of the incoming goods streams is not happening, then that ship is not going to be fully loaded, for example. And then reciprocal, meaning that success is contingent on a group of actors working interdependently to complete a project. Project fails if they don't continue to share information and react to each other's progress. Typically here would be the port and ship interaction, where you will see that, okay, now the port is delayed, the ship can slow down, or now the ship is not meeting the timing to the port in the right time. So Maritime Informatics then is, to repeat, a science for change. It requires engaged scholarships and reflective practitioners. It is highly emphasizing that you should not pave the cow path. And that goes back all the way to Mike Hammer and Thomas Davenport and these guys that did the business process engineering era. saying basically that if you digitize, you may actually put into the computers the bad behavior. And it should also be a driver for the maritime education and training of the future. And we have made some statements on that in association to Seaways, where we see that we put some emphasis on what would the new digitalization course drive us towards. These are statements that we are complementing the reflective practitioners and the engaged scholarships. And again, we have these 3 focus areas of maritime mathematics on digital collaboration, digital data sharing and decision making, and data analytics. So, having said all this, let me then try to elaborate a little bit on different challenges here. And the first challenge that I would like to emphasize is, can we actually manage to get to a point where we enhance the predictability of sea operations? And I think that maritime operations is actually one of the weakest chains that we have in the global supply chain. I don't know if you agree with me now, but it is. I have a lot of cases where, for example, we have booked a train. It is 20% empty due to the fact that the train has been subscribed to by one of the largest Swedish cargo owners, and it's 20% empty due to the fact that they cannot really predict when the goods will be possible to onboard to the train. Second challenge is what I almost feel ashamed of, is that many transport buyers, or what we call shippers, freight forwarders and the cargo owners, they are experiencing the global supply chain as a very big black box. That's why we introduced what we call the virtual watchtower networks, or VWT, which we highly invite the companies of the world to be part of. And the third challenge, which has become a very big concern for myself now, is to respond to the needs of decarbonization. So, taking the first challenge, enhanced predictability, we believe that we can manage to enhance predictability by standardized data sharing, shared situational awareness, and data-driven decision-making to balance capital productivity and energy efficiency through ecosystem collaboration. This idea is highly pushed by IMO. I don't know if you've seen it, but it's something called a just-in-time arrival guide, which is basically saying that stakeholders across the supply chain need to share up-to-date, reliable information about each vessel's location, its speed, and the shipment it carries, as well as data on terminals and locations where the shipment may be collected or delivered, in order to efficiently connect maritime vessels with other modes of transport, such as road, rail, or inland waterways. And maybe you are familiar with a concept that was brought forward by us. We were in the leadership of that, called CDM, collaborative decision making, and port collaborative decision making, which was basically mimicking what happened in the aviation sector, where you needed to have a slot time in the other end in order to take off from one airport, and that's fully implemented in Europe now and controlled by Eurocontrol. It wasn't really 100% successful in bringing this to the maritime sector, because it is a kind of a difference when the flight may be maximum 15 hours in the air, or 18 hours maximum. Very many European flights are we are counting 1, 2, or 3 hours. And what you didn't want to do is to circulate above the airport. You want to have a green in-flight, where you basically turn off the engine when you approach the airport, and then the airport should be ready for you. That is not really happening in the maritime sector, because the ship might be out steaming for 4 weeks. So it really doesn't really matter. But on the other hand, the principles of data sharing are similar. When is your planned time of arrival? Can you please update your planned time of arrival? What is your estimated or calculated time of arrival? And what is your actual time of arrival to previous nodes? So we brought forward that in what we coined as a metro map, where in a port call, the different actors needed to exchange information with each other in order to be secure themselves. And interestingly, the predictability of the arriving vessel or the arrival of the vessel was pretty good, but the departure was really bad. And that is probably due to the fact that so many participants involved. And the conclusion we drove is that there is no one that sits on the whole truth. We need to combine data from many different sources. Pieces of information needs to get to be brought together, and we need to empower the awareness. One of the big now in the industry is that it is a lot of assumptions that we are making when we are talking about, for example, carbon emission calculation, etc. So port collaborative decision making or a process of collaborative alignment is a foundation to move from coordinating based on physical presence to virtual coordination. I know that, for example, the Panama Canal is introducing slot times, for example, but it's very rare when it comes to port operations, etc. So this was brought together in a concept for digital collaboration that we called CDM. Multiple industries, so transport industries, both for the railway sector, for the maritime sector, and for inland terminals. We have it in the aviation sector, etc. And it's all about that people need to be coordinated based on situational awareness that you share, that is commonized, that we have different principles of collaborations, when to exchange what and with whom. Standardized exchange of timestamps, both estimates and actual times in real time, and also having some kind of coordination principles from common goals, KPIs. So a typical discussion I would have is what kind of performance should we as a port with all its conglomerate of actors actually respond to in order to make that happening. The approach that we are taking is that we are adopting something called a living lab approach, where actors come together and collaborate related to a certain concern. We ran Port CDM in 13 test beds in Europe. We exchanged about 2 million timestamps, and the actors said that in these 13 different living labs, all living labs said this is the first time ever that we meet together and discussing this concern of optimizing port calls. We thought that CDM was such a good idea, so therefore, in our second challenge, as of today, to open up the black box of global supply chains, I stepped into. Do you know an organization called PSA? PSA is one of the largest terminal operators in the world. It is about they have sites at or 52 different sites. They have a turnover of around 100 million TEUs. Or container units handled. And I said, I want your data. And they just laughed at me and said, why would we give you your data? Now, it's not for me, but it's for Stora Enso. And maybe you know the company Stora Enso. It's a pretty big wood manufacturer up in the northern part of Sweden and Finland, because they want to know what is happening with their containers. And then they immediately said that, of course, you will get that. We will be a logistics service provider of the future. So we coined what we call the shipper-driven and then terminal-centric, which was very interesting also because it's very hard for anyone to tell that the ship should be moved in another direction or visit another port. They live their own life, so to say. But when the ship comes, if we can forecast before the ship comes to the port or the truck or the train or whatever, to the transport node, we can actually handle that unit in another way. So, for example, if Ericsson, who is one of my partners, has an incoming container to Singapore, it misses the connection. It might be reasonable to fly that from Changi Airport instead to the because the factory needs the semiconductors. That could be the case, not heavy goods, etc. And this is to compare with, if I miss my flight connection from Amsterdam to New York, the flight company doesn't tell me that sit down here in this chair and wait until the airplane comes back again, and then we will see whether it is room on board. They will handle it somehow. but that is not happening in the cargo transportation sector. So we coined it as managing risks in supply chains, in global supply chains. And the vision here is to create an ever-growing global community that co-creates a digital middleware or co-creates VWT net, is like internet of virtual watchtowers for enhanced visibility, supply risk, and supply chain risk management through private and public data-driven analytics and collaboration. And what my cargo owners are saying is that we need higher supply chain network visibility. We need better risk management to better deal with, for example, disruptions and greenhouse gas emissions. We need to balance costs, reliability, and sustainability. We need to come to more large-scale digitalization, but also better collaboration across the industry. And here I think that neither we in Sweden or you in India can be isolated from this situation. So some key characteristics was that we built on the idea that we have a collaboration and digitalization acting in symbiosis, a distributed network structure of VWTs, and maybe you know about the concept of trade lanes that Maersk and IBM brought forward. I think they invested $100 million and they failed. They closed it down. So one could claim that was kind of a centralized solution. So what we want to do is to really push the distributed nature of VWT-net to its extreme. It's leveraging private and public data. It builds upon descriptive, predictive, and prescriptive analytics. And we have this power of attorney that we now have signed from the cargo owners saying that you should share the following data into the system, and trying to push the fact that we want to surface more primary data coming directly from the source, and also then adopting a minimalistic approach. And for the first time ever, there are 3 research institutes that came together: RISE in Sweden, or Research Institute of Sweden, A-STAR, which is the Singaporean equivalence, and VTT, which is the Finnish equivalence. And we are basically now bringing forward the possibility to collaboratively act where you are in the same competitive space. So DP World, APM Terminals are asked to join. We'll be extremely happy to have them on board, and PSA is welcoming them. And I think that the reason why we can do this is just because we are standing on neutral foundations. So the initiating community are these companies, and some you may recognize, and some are the biggest in the world. And empowered by Neutral Research Institute, the project adopts a community-driven approach, engaging in diverse set of partners to co-create a VWT prototype and prepare for global adoption after 2 years. So let's see. You will hear more about that, and we are a very inclusive approach here. So if you have anyone that you feel that should be part of this, please feel free to reach out. We do not yet, for example, have any train operators in India. That might be something. Green Cargo is a pretty big one in Sweden/Europe, but why not that? So just to reveal a little bit of the vision of this, I will now play a video that shows VWT. It's just 3 minutes.
The Virtual Watchtower Network, the VWT, is a solution designed to raise visibility in end-to-end supply chains. As a cargo owner-driven port-centric partnership, the Virtual Watchtower is a machine-powered solution to secure on-time deliveries of orders to customers all over the world. Here's an example of how it works. 10 containers from Northern Forest destined for Australia have been shipped by rail to Oulu in Finland, where they are loaded onto the feeder ship Hara 5. Cargo is exposed to risks. Ideally, all the parties concerned can monitor the merchandise moving from origin to destination. Hara 5 has lost some time in a storm. The ship's Global Fleet Operations Center in Copenhagen is updated on the situation. If they stick to the original plan, many containers will miss their connection at Zeebrugge. The captain of the Hara 5 and the operations center collaboratively assess the situation and the captain decides to follow the machine-powered VWT recommendation and increase the ship's passage speed to make the planned arrival time. On arrival at Zeebrugge, the personnel in the port's control room monitor the reloading of the 10 containers onto the Blue Ocean, the ship that will deliver the cargo to Sydney via Singapore. An update on the successful port visit is delivered to the operations centre in Copenhagen, and in turn to the ports and each cargo owner. On the way to Singapore, a new incident emerges, a potential wait and delay in the Suez Canal. The VWT immediately identifies the cargo and the affected cargo owners. The VWT flags and alerts the potentially impacted parties. In a virtual situation room hosted at the VWT, the network's members from different organizations and places across the globe discuss the incident instantly based on analysis provided by the VWT. On this occasion, an update arrives that the situation has been resolved. After an on-time arrival in Singapore, the Blue Ocean's reloading of cargo has been monitored and shared with all parties involved, thanks to the VWT. The ship is on schedule for its destination, Sydney. Whether your cargo travels by sea, land, or air, the VWT is a new way of ensuring sustainable, safe, secure, and on-time transport. We thank our partners for supporting the Virtual Watchtower project. Contact RISE or A-Star IHPC if you're interested to join.
So everything is really about enhanced data pools arriving at collective intelligence, collaboration, and better decision making. That's where we want to get to. And you saw here an example of how really real-time virtual collaboration actually can take in place. So taking the last challenge, which I think is, maybe I should have placed this first, but this is of a high concern, responding to the needs of decarbonization. I had the opportunity to meet Professor Benjamin Horton from Earth Observatory of Singapore, and the facts that they are bringing forward is really, how should I call it, it's not looking good. So we have estimates that the global mean temperature is going up. We have an annual average temperature rise since 1850, and it's just going up. And I think that we are in a position where we actually need to start thinking about how it would be to live in a world which is having such a temperature rise. Is no way that we can meet the Paris Agreement, is my opinion. And we have a problem here because in the maritime sector, if you look into that, we're talking about maybe already talking about 70,000 ships, and we found out that they were owned by 15,200 organizations. So it is very much more than Maersk that we're talking about here, or MSC, or CMA, CGM, or Hapag-Lloyd. It's very many shipping companies. And I doubt that they will afford to retrofit what is needed or order new builds, what is needed to actually cope with this situation. So what is at stake? We have the Atlantic circulation, meaning that the Gulf Stream is actually slowing down. We have an accelerating ice loss in the Greenland ice sheet. We have the Arctic sea ice that is reduction in the area, and that's also where we are starting to explore new routes. We have the permafrost that's thawing. We have the mangrove and salt marshes, which is a loss of ecosystem. We have coral reefs with large-scale die-offs, etc. And we are talking about situations where you would have much higher waves, more storms, more flooding, etc., which is affecting us very much. And now I have a new number. Transport stands for 28% of the greenhouse emissions, but it is a big portion, that's for sure. the maritime sector is not the biggest one, the biggest polluter. It is the truck operations. That's not, or the rubber wheeled associated transports. The absolutely best one is electrical trains. That's for sure also. So we have this situation, and I think that if we reach 3 degrees, I think that Benjamin Horton said that the world can only cater for a tenth of what the amount of people that we have today. So what we did was that we brought forward and started elaborating, okay, how can we then enable and support people in the efforts of maritime decarbonization? And scenario analysis, we built a framework on 4 components for determining decarbonizing actions. One was scenario analysis, one was value chain mapping, one was enable prioritization, and the last one was partnership selection. So I will just share it, not going into detail, but there are different scenarios that I would say the oil industry is talking about, because this was very much generated from my collaboration with Shell. You have swells with uncertainty about key decarbonization technologies, but pioneers, private and public actors undertake strategic moves. You have storms, which is more of a sluggish global trade outlook and focus on domestic economies, adding friction to accessing capital for new investment in new and greener technologies and practices. The storms is very much of going towards islands of things happening, and I would say that given the geopolitical constraints that we are concerns we're having at the moment, we are very close to the more of the storm strategy. And then we have the clear sky, which is basically saying that we need coalitions that collaborate under the theme of decarbonization. I would also say that the European Union is very much of a forerunner at the moment on trying to reduce greenhouse emissions. We hear that story more on the European side than in the rest of the world at the moment. I don't know if you agree, but I think that's what's happening. So just to point out a couple of things on this perspective, what we came to the conclusion of is that it's not enough to just look into the operational value chain of maritime transport. We also need to consider shipbuilding and also marine fuel value chains, meaning that there is something from the well to bunker, and also we need to secure that the ships that are being built both responds to possible available fuel, but also that the ports are adjusted so that they can handle the size of the ships, etc. In Sweden, I think it is 20 billion kronor investment in upgrading ports at the moment, just to cater for the new situation. And I guess that you are building new ports in India as well in different ways. So that is seen as a very important alternative. But that also means that it puts focus both on ports and ships in order to make this happening. And one perspective that has been pushed very much is the port as an energy hub, and that is something that is coming forward now, which again will require digitalization in order to be coordinated in different ways. And those what we also did was that we identified a number of different enablers for this, sorted in concerns that was within one chain, between 2 chains, or between all chains. And here you see a number of different enablers that we can talk about, everything from just-in-time port call operations to regulations to which fuel to use, and which or other power sources such as nuclear, for example. So if you want to read more and learn more about that, we brought forward these books with highly prominent experts in the world, with the 70+ contributors that was released earlier this year. No, actually last year, and end of last year, we had the launch seminar on the 9th of October. So having said all this, I am now coming to my conclusions and saying that more data will be surfaced, providing opportunities for enhanced situational awareness, becoming the key to allow each involved actor to take conscious decisions. The transport and logistics system is self-organized or self-organizing. It is fragile. Seamless and holistic perspectives are needed, which is something that Maritime Informatics can provide us with. Collaborative and digitalization approaches are needed for economic and societal benefits. So maritime informatics is an applied science for the maritime industry. It engages both practitioners and researchers for a common goal. It promotes standardized digital data sharing throughout the cargo chain. It supports the enhanced efficiency, safety, security, resilience, and sustainability in maritime transports. It enables us to understand, predict, advise, and improve maritime activity, and enabling the seamless integration for the larger transport system. It is the key for the future of maritime transports. We have, as you probably have understood, we have now tried to embark on 3 different collaboration clusters, or where we are mobilizing for collaboration and co-creation to respond to the needs of today's and the future economy and society. One is maritime decarbonization. The second one is maritime informatics, and the third one is a virtual watchtower initiative. If you want to read more, I just negotiated with Springer that allows us with a 20% discount on the books. So you access them via maritimeinformatics.org or maritimedecarbonization.org with these promotion codes. So hope that you would like to be part of the community and be inspired and contribute. And that's approximately 1 hour short.
Thank you so much, Professor Michael. That was fascinating. A lot of very significant messages were there. For me, the biggest eye-opener was how you're solving some of the global challenges using the maritime informatics. And what is very, very clear is, one, it enhances the predictability, but also how collaboration can be improved. And also, more importantly, how you're solving the decarbonization problem. I think that is really fascinating. And what you said can also be extended to other modes of transport. It's not just maritime, but so that was general in that particular context. I see a few questions here as well. Would you like to take a few before?
Of course.
Like there was a question in terms of what are the steps taken by the IMO to reduce the maritime traffic in general? Would you have any thoughts on that?
So I would say that, okay, I think that the question that actually opens up, we can challenge that. Are they, should they, or are they taking steps to reduce maritime traffic? And I still think that moving, if you think about it, the biggest container vessels, they can carry 25,000 containers. If you then have one container with, I don't know, 1,000 packages of shoes in that, the carbon emission generated from that sea transport is very little for that pair of shoes. So many would say that it is a very sustainable mean of transport. What though is happening is that more and more regulations are coming from IMO on which fuel to use in order to actually move the goods. And there are many different rules, and you have everything from carbon capture and storage techniques to ETS trading system, etc., etc. But there is for sure very high up on the agenda for enabling better sustainability or energy efficient seaborne operations. Part of that is also, of course, that data is being shared so that you can be prepared in the receiving end for an incoming ship.
Great. There's a next question is focusing on whether you can help understand what is digital twin. I think that's a long question, I would say, long answer rather. Short question, but it'll take a bit of time. But if you can just like in a few seconds.
Thanks a lot for the question. I would say that so there is if you go to Maritime Executive, you will find an article on digital twins. You can also go to the latest number of the UNCTAD Trade Facilitation newsletter, and there we also put that framework forward. What we said is that a digital twin builds up on that you have a mathematical model on what you want to pay attention towards. A digital twin needs to have or be trained and have a feed of historical data or a data lake with those, but it also combines with real-time data. It needs to add situational factors for different contexts, etc. And the big thing about it is then to utilize that model in order to simulate the outcomes of different scenarios. So you need to define a scenario as well on that.
Right.
So that's a short answer. And I think that what we more and more are heading towards is that not just replicating a physical machine like an engine or a ship, etc., but rather also start to think about more human practices that are digital twinned.
Great. I think this question links very well with this digital twin, which is saying that several vessels are berthing based on first come, first serve, but can we use the virtual tower, what you mentioned, to address this challenge? For example, it can be speed up for some vessels and can be, yeah.
I think it's a good point there. What comes to my mind is that I don't think that the transport and logistic industry can be changed or disrupted from an inside-out perspective any longer. I think we need to utilize the power of the clients of the industry. So, and that's what we are trying now in Virtual Watchtower by saying that if you're not complying with these needs of data sharing, you're off the vendor list.
Right.
So maybe I say this is one way to get the people listening into it. And if you then start to share more data from the primary source, what are your plans, and get updated plans, etc., you have a chance to actually respond or to get to a better predictability. And that must be better than just saying, hey guys, now I'm here. I told you 24 hours in advance that I'm coming now. 24 hours, that's nothing if you want to plan your operations.
Right. Yep. There's a question by Dr. Saha. He mentions about, we discussed a lot about maritime informatics for the last mile decarbonization. And the question was, well, maybe we need more collaboration with the inland transport for a common goal of decarbonization. I think it is more of a agreement question.
I'll say yes. Then maybe I should comment on it and say that I think there are two dimensions to that. When I talk to some of the biggest cargo owners, they are really both thinking about how do we make the combination of sea to road, for example, as good as possible, as energy efficient as possible, but also thinking about how shall our network be looking like. So, I mean, if you're buying transport for 1 billion euro, of course you have muscles in order to think about whether maybe it's worthwhile to steam a ship all the way down to Italy rather than bring the stuff on board a truck and driving it down through Europe. So there are multiple dimensions coming to that question. Right.
A follow-up question is more also on the decarbonization, but a different angle altogether. The question says, with increasing number of vessels coming under attack in the Bab-el-Mandab route, do Northern Sea route and the Northwest Passage looks like something the marine industry could explore, with caution, of course, on the decarbonization and conservation of the local ecosystem. I think it is probably to do something on the
but then another thing there, and that is also, I mean, you have a strong geopolitical concern of Russia at the moment. So I am not 100% sure. There are other trends as well, because you can also see, I think that China, wasn't it China and Pakistan, or China and, I think it was Pakistan, if I remember, but in that just between India and the Arabic Peninsula, you actually have transport going through Pakistan, and then you pick up the goods there instead, which is also affecting the whole trade pattern, instead of going to Shanghai and Hong Kong and Singapore to pick up the goods. So there are different routes absolutely happening. I think one of the challenges with going around Africa is also that you have the situation that some ships probably need also to go into ports in Africa, and African port infrastructure is not on the level of what we have seen in crowded Asian ports and also in European ports. That's
right. So a question is that how do you see the maritime bunkering system changing, and which fuel is most likely to replace oil by 2050 net zero? I think that is a question with large wisdom.
Let me say that this from if you take it from a shipping company point of view, I think that it has been a trend lately to order methanol ships. If you go to the European Parliament and talk about LNG, they will say that it's out of the question. LNG should not be there. If you also think about it, how long time did it take to establish the fueling infrastructure of LNG? It took 15 years. So, and what is main fuel hubs such as Singapore, Hamburg, Rotterdam, etc.? What are they doing? They are basically saying that we provide you any fuel that you would like. So, I would give a good bet on methanol. I would also give a good bet on taking away the combustion engines and rather use hydrogen to generate electricity. I think my feel at the moment is that ammonia seems to be rather dangerous, but I also see efforts in trying to get ammonia in as a fuel alternative.
Right. I think we'll take this one last question before we close. It seems that some regulations for efficiency, example, support for slow steaming, can be in contradiction to what would be the most efficient flow of goods, example, just-in-time arrival. So I think it is saying that both the policies kind of interacting and contradicting each other. And how do you think about EU IIMA possible sub-optimization kind of things?
Yeah, this is hard because taking it from a holistic perspective, if you can manage just-in-time arrival, then everybody can plan according to that. But we also know that there are so many factors that can affect a ship when it's steaming. And also what we experienced in Felixstowe, for example, and also in LA, is that we didn't get the containers out of the port. So basically we have blank sailings in Felixstowe due to the fact that there was a lack of semiconductors and drivers. And it even went so far, so the US Armed Forces stepped in and supported the operations in the port in LA. So I think there are so many dependencies between different actors. So I would not say that slow steaming would be the solution to everything. Absolutely not. But optimized steaming would be a better way.
I just missed a question by Santosh. She's asking if there is any standard initiative or benchmark for ports intralogistics, specifically with respect to digital twin. Is there any policies or any kind of framework out there?
And ports intralogistics means the logistics.
Yeah, I think container movement within the equipment and all of those, yeah.
So we developed, and interesting that you said that, we developed a concept for what we call the sustainable port, and we divided that into the port as a transport node, the port as a digital node, and the port as a energy node or energy hub. And with not acknowledging just the window to the sea, but also windows to the trains and to trucks. And that gained a lot of attention, and I can share the link to that, of course, where we have written those concept notes, so to say, in English also, so those are conceivable. I would love to explore the concept of the sustainable port in India.
Lovely, lovely. No, I think those were all fascinating answers. Before we close, I would also do a little bit of announcement. At IIMA, we are actually offering a 3-day executive education program on port design and management. So if any of the participants are excited or interested in these, please register. So this is something we are looking forward to. And for the evening, we'd like to thank again Professor Michael Lind for all the presentation, but also answering the questions so patiently. A lot of interesting takeaways, and I'm sure this is not the last time we're having him here. We'll have his multiple times with different concepts and different ideas that he can bring on the table. So thank you again, Professor Lind, for doing this for the center today. We really appreciate this effort, and thank you again, all the participants, for joining. Have a lovely evening in India or wherever you're joining from. Have a nice rest of the day. Thank you again, Professor.
Thank you.